Yes. So the first step for me was to choose a category because I was into um, like electronics. I chose the category of computer and accessories. So Amazon has, as you know, has different departments, different um, categories you can choose. So if I go to, for example, Amazon, um, so that's how I actually chose it. So you can see here is electronic, which is the main department. So from here, you can get to choose whatever data you can extract. So here is computers and accessories. And you can see within the computers and accessories, we have subcategories. And the subcategories, if I can find it here, is laptops. No, actually, it should be here somewhere. US. Yeah, computers, laptops, desktops, monitor, tablets, computers, accessories. All of these are subcategories within the main categories. If I go to the computer accessories, you can see actually we have all sorts of computer accessories here. But for me, I chose the main computer and accessories. So the first API call was the API call to send the API call to the computer and accessories. So the API call to the Keepa is the result gave me all the subcategories within computers and accessories. And the script I ran, it sent the API call to the endpoint. If that endpoint result had subcategories, still send the API to all the subcategories until it reaches the leaf level, meaning that we have computers and accessories, we have computers, we have laptops, and we have tablets. Within laptops, we have within computers, standing computers, we have towers, we have I don't know, minis, and all the way down. So the first stage was to sending the API call in order to get the ID of the category tree that I want to extract their products, the ASINs, because one product might be in electronics and it might be in like I don't know garden as well because they are electronics. Like if it's I don't know like automatic grass cutter, it might be in electronics, but specifically I wanted the products that are in the computer and accessories within the electronic department. That's why I went over hierarchical data extraction. From there, I extracted the number of categories. Here I can show you real quick, which is going to be my Keepa. Actually, it's not in my GitHub directory repository. So, extract. So after extracting, so these are all the categories paths that I extract from the Keepa API. And from these the main categories was the leaf category that I wanted to extract extract the ASIN names. ASIN basically is a specific identifier for each Amazon product. So these are the leaf categories. If I extract any product ASIN from these endpoints, it means that product not only lives in this category, but also has the tree or hierarchical tree relationship back to the department, which is the main category. I made my API calls, extracted these, and then from there, I extracted the list of Amazon identifiers for all the objects that are within these categories. However, there are thousands of products for sure. I did not have enough subscription and time to extract all of them. So I got my extraction code to only extract 200 from each. And then, so what I had here was just a list of asyncs, the list of identifiers that I was pretty sure I want the product data, historical product data from the Keepa. So from there, I send another request. I read these product asyncs and send a request to the Keepa endpoint for these products. And the result was a JSON file, like a huge JSON files. I think my final JSON file was about 300 gigabytes for all of the 900 products. And then from there, I use the same asyncs to send the seller data who are selling these products. So the seller a name, their ID, what the condition of their product is, what the shipping cost is, everything about the sellers, different prices of this data, and all historical. And what I mean by historical is the data from back in 2023 of the price, date of the price, I don't know what condition has at that time, like any coupons was applied. So with that, I had the whole data, even for the prime weeks that data was dropped. If any coupons was added to it, I could actually use those data. So then the next step was to transform and load it to my Snowflake. Yeah. Go ahead.
Doesn't Amazon have rules about getting that amount of data out of just a general category of information from the website? Or how did you attain the privilege to get that data is my question.
Yeah, actually these, I don't know how, but in this platform, which is legit, the Keepa, you buy a subscription, and you can see right now I only have 60 tokens available. I guess the information that Keepa gives you is not all the information that Amazon itself has. It does have limited, sometimes the data from the Keepa was so dirty. So in order to clean it, some of the data was encrypted. So I saw in my transformation script, I have to decrypt this data because they're storing a huge number of metadata, but it's limited. It's not the same metadata that Amazon itself has. But this platform, this website is a website that you can have by subscriptions, and you can track the products you want if you want to buy and sell stuff. But yeah, it does have different endpoints that you can use, basically. And that's historical data, and the other one was yes, is this one which gives you, it's the same platform. They have notifications if the price drops and stuff, if you have subscriptions, but this is the endpoint. You have API keys and you can send a request back and forth. But data is limited. And Amazon does have something, but you have to be specific. You have to be a customer who is selling to Amazon like more often. They will give you APIs. So as I mentioned, I realized I had limitations on getting the data in one day because I wanted my current price of the Amazon to compare with the past prices. So these were like 1 token for product, 6 token for each offer from each product. If I wanted to get ratings, extra 1, stocks, and buy box information. So the same day prices was not available for me. So as I mentioned, if I send the API request for 100 API products, I wouldn't have any APIs for the next hour. 1,200 tokens per hour, it takes time to regenerate. So the impact was that I could not get the current buy box prices and the recent month sales of this specific day. And I couldn't capture the offers that was online on that day. I needed those information. Also the other features, Prime, fulfilled by Amazon, condition, for each offer, for each seller, changes every day. Because a product that you see on Amazon, basically the buy box was confusing for me at first. The buy box is different than Amazon's price. So I'm selling this cell phone, and people are saying the same cell phone. Let's say I'm on Amazon. I sell it for $100, which is new. I ship it for free. I have it in my warehouse, but another person sells it for $6.99 with the same feature. So that person wins the buy box, and then you see the product. That's a buy box, and Amazon might have the always. Same for used products. So a used product, maybe selling this cell phone, which is like new, $600, and shipping, but another person sells the same version, like new, however, it's not shipping. So the one that shipping wins. So this information either changed every couple of hours. So that was important for me because with Keepa API, I could not get correct data. So list of the data sets that I could extract from Keepa, which worked for me, was the categories that I had asins, category tree, category name, and category levels. These are after my transformation. My transformation for each of the tables are like that, transforming from JSONs to CSVs. Historical data has Amazon's, for each product I have different values for each date, and the type ID for each product we have 32 type IDs. Type IDs includes each number maps to one date. For example, one maps to Amazon price, two maps to price, three maps to used price, 10 maps to condition ID. And these are all historic data for 32 values for each Amazon product. That's all historical data used for only for predicting the future box sellers, predicting the future revenue, but also for my time series analysis. I had historical buy box, which shows the historical buy box winners, 2023 up until now. Historical monthly sold, which product showed in each day, in each date, how much was previous month sales was. Historical offers that for each date showed like all these information, what sellers, what conditions, was it Amazon, was it fulfilled by Amazon or merchant. Historical stats, which showed the average window, means that average 30 days, 60 days, 90 days, 180 days, and 360 days, with the same IDs I explained for the stats, meaning new price, used price, and different information, warehouse price, eBay price. The seller profile was another thing that it gives you like in-depth information about sellers. How many percentage they had 1 star, 2 star, 5 star, and this helped me identify the true rating for the sellers. The seller data also had, I think if that was vice versa. The seller data was having like the detailed information like seller name, current rating count, how many rating they have, their final star rating, how many new products they have, how many used price they have, positive rating over 30 days, 60 days, 90 days, how many ratings they have in 30 days, 60 days, 90 days. And these are that was useful for me for the historical analysis, series analysis. But see, I don't have any current data right now, historical. So that's, we go to the second extraction, which is extraction, which have its own extract, transform, clean, and load to Snowflake, and do and data model with Python and load to Snowflake. And the other way around, I extracted, transformed with Python, loaded to Snowflake, and from there, I cleaned the Snowflake and and created my data models within Snowflake. So this one is a specific the second one. Right? This one explains the step-by-steps of extraction, transformation, not loading to Snowflake, and building model. And so that one I forgot to mention. So then next step was the rainforest. Rainforest, as I said, current information, automated workflow, same as before, but this time I had the asins, because in the Keepa I already extracted the Amazon asins that I want to send the API. The only thing that I did, as I said, the scripts for extraction is different, 2 different APIs, 2 different HTTP headers, and different Python libraries. So with this one, I feed my asins to product endpoint. I got the final product results, which shows for each product, it shows the final price, final current buy box winner, what features they offer, and also use the same asins to extract the other offers. So for each product, other. So I'm one as a buy box then right now at this stage, so the Rainforest API documentation to get that recent month sale and the product. So basically for the product that's the API. So I search of the Amazon. A lot of only needed the recent month sale. So here are data sets I needed from the Rainforest. Product, which shows current information product I need in, title, what's the brand, price, who seller, which is a buy box winner seller, seller ID, availability, and it all has availability, as you know. Used, new, used, excellent, refurbished, and all kinds of stockability. Is it Prime? Is it Prime exclusive? Is it sold by Amazon? Is it fulfilled by Amazon? Is it new? And all these Boolean values. Is it Amazon's choice? Has any coupons applied to it? 5-star percentage means like 5-star percentage of the ratings. 5-star counts, how many people done 5-star to it, 4-star, 3-star, 2 to 1-star, and the date. The date was the day that I extracted. I think it was January 14. So all these data for the offer, and the next one was for product. For the offer, for each product, I had multiple rows, meaning multiple offer from different sellers. For each product, I had multiple seller names, seller ID. If they're a bar box winner, it's a Boolean, because for each product I might have 4, 5, 3, whatever number, but it's a 0 or 1 transformation. Seller total that person is offering. The price they're offering was by the merchant. These data are coming from my offer transformed CSV, that is bronze layer of my recent sale. Can be 0, basically null, but 0. Some products have like any recent sale last month, it wasn't in the JSON, but I made it 0. You can see the example of. So we've extracted our products information, transformed it in a CSV, and we are ready to load it. So what we're loading here is combination of static data from rainforest and historical data from Keepa. But here's the, there was a little teeny tiny issues here. Because I was extracting information from 2 other resources, sometimes a product is offered in Keepa, but it's not in rainforest. But a Keepa in here was winner, as I realized, because I extracted 900 products from Keepa API, but when I fed the same ASINs, Amazon identifier, to Rainforest API, I realized, so whenever you pass in the header request, in the header request you pass to the Rainforest cannot find that on ASIN, it will, I'm glad that was within the category that I access. It reads the same product, so I had duplicate. So from, I think, 900 products that I extracted from Keepa, about, I can half of it from rain not be found. So extra snowflake. So if everything data I have on both, I needed to regular cleaning tasks, like values, data spaces. However, extra cleanings I had to do because the data was not complete. A lot of using my data, so I had this issue. In the Rainforest API, whenever a product seller or buy box winner was Amazon, the Amazon ID was missing in the JSON. That's, I realized it because I saw for some products the seller ID and seller name was null after I transformed it, and I realized that was missing in the JSON. And I realized that in the JSON, they're not, when the Amazon is winner, they don't say Amazon. They don't assign any identification for seller ID for the Amazon. But I had those in Keepa API. So I had the Amazon.com and Amazon resale, and I had the identification for that. So I needed to join these huge tables together to bring the Amazon name and the ID to my in Rainforest. Went to our Amazon, easy. In my Rainforest offer, I could see the times that Amazon bought. Remember, in is, so I found a column called is winner. In 5 offers, if it's yes or one, it means that one won the buy box. And I had that my and I buy box winner in my Keepa. So I just had to join them, not but on the winner, so that I could grab the ID and merge them together. Meaning that I had to perform because of match API calls. After the data into Snowflake, And final day with the Snowflake, I could just extract my queries from. So my bronze level was, I loaded my everything from my local host to the bronze level, raw data, no changes there. The silver layer, I perform my cleaning tasks, duplicate, deduplication, data types, Boolean normalization, widespread cleaning, and those extra API required cleaning that I mentioned because of the mismatch between the two APIs. So I wanted to do that in my silver layer because I wanted everything clean in my silver layer before I start my modeling. So this is an example of one of the tasks I've done for my recent sales. So this is, I think it doesn't have too much here. It just says like a train async, and I'm just extracting the asyncs where it's not in my key. Has more data. I wanted to have same number of objects in my both data because like the historical data had thousands, 7,000 of rows. And, I did not have most rainforest. I didn't need all of that in because that was free trial. I was charged for number of data that I have there. So this is another example of the cleaning silver products. So first, realize that availability when the product is not in stock. We have data in stock. We have data when the product is not on stock. So I replace it with unknown and update the product seller. This is an old code that oh yeah, here, this is an old code because for Amazon.com, I actually had the ID in my Keep API. So I used CTs to extract this ID from the other historical data set. But Amazon resale, I didn't have anything. So this is something that I manually added to it because I had data for them. So in here, I said when the product seller ID is Amazon, assign this ID to it. If it's Amazon resale, assign that. This is a simple cleaning stuff, deduplications. These are example of my silver layer. And in here, deduplicates only those asins that are present in offer as a buy box. So in here, in my silver layer product, I wanted to have only the buy box winners. So in here, I was making sure that I joining to my offers table that has multiple offers per product and only making sure that price that I have in price is actually buy box price. So I join it on the same product ASIN, same seller name, so meaning the seller name and the buy box winner on the offer, so that here on my is one are my silver layer. And here I exclude the duplicate sins and I just join these two together. Join exclude asins, these are asins that are buy box winners, and I'm joining them with the one with the buy box winners. So I have the whole information from two different APIs, the making sure I'm capturing only buy box winners in my main product table for future analysis. The next one that here is the example of what I did for the seller. Excuse me. So here, with first CTE, I extract the seller IDs and seller names, and here I say if the seller name is not null and seller name equals to seller name within the seller data. As you remember, seller data was the huge data set Keepa that have all the seller information all correct in it. So what I did is that I said, if you remember also, I mentioned that in the Keepa API, when the Amazon is a buy box winner, seller ID and seller name are both null, right? And this is example of cleaning procedurally, not doing it by hand. So I say in my Rainforest API, if the seller name was null and seller name in my Keepa API was not null, use the seller name on Keepa API. Because both names on both tables, data sets are the same. I check that. So for example, I don't have somewhere Amazon, in another one Amazon.com. I don't have Lenovo, and in another one Lenovo company, something like that. Both are the same. So I said, whenever this one is null, but this one is not null, use the one from the Keepa. So I filled out the missing data from my rainforest using this method. But when it's null and the seller name is null there, just use the one we have here. And that's the way to bring the seller name. And I did the same thing for seller ID. Here in my offer table, I mentioned that for Amazon, I did not have any items. So what I did is that in Amazon seller CTE, from seller table, which was a huge information, I said capture the seller ID and seller name where the seller name is Amazon.com, because I knew that Amazon resale is not mentioned in any other. Just to have the Amazon.com, because like Amazon is more like it's less efficient than when you do the equal to Amazon. That make the query a little bit faster. So I used, instead of is like Amazon, write the exact name of Amazon.com. So from there I had seller ID and seller name of the Amazon. So I updated my offer table so Amazon seller has the seller ID. And you can see here for Amazon.com seller name, I use the seller ID I capture from this CTE, right? But for Amazon resale, which I didn't have in my Keepa API, I said whenever in my offer table, which is from Rainforest, I have a seller name is like Amazon, but it's not Amazon.com, because I already said here when the seller is null and a.seller name is null. When a.seller name is null, it means that the seller name in Keepa API table is null too. It means that it's Amazon resale, because Amazon.com already we have the seller ID. When that's the case, it means that it's not Amazon.com, because Amazon.com was applied in the upper condition. In this condition was applied the ID to the Amazon.com. But in here, I says when the seller name is like Amazon, apply this manual ID that I implemented. And as you can see at the end is Amazon, so I wouldn't apply these IDs. So this is something that I made. And the final selection is cleaning, trimming the names, make a booleans to 1 and 0, making sure the data are correct, making sure I have my annotations here. So for example, seller percent I have here. But at this point I don't have like complicated applications, just simple applications. These were some of the examples of my transform on my raw transform data that I imported. So by the time that I'm here, all my silver layer tables are ready. All of the transform data are cleaned. The data is prepared for my data modeling for my gold layer. So before doing anything here, before moving forward to my data modeling, if you have any questions, I know I jumped from the different APIs. back and forth. It was complicated for me at first. So, any questions so far? Okay. Um, for the for my data modeling, I decided to um, go with as much as a fact table as I can because I had different types of data: seller information, seller details, historical data, historical buy box winner, historical different types of historical data I had. So I created a bunch of. I actually can open my Snowflake pretty quick here. Um, I try to have as much as fact table as I can, and try to have create lookup tables as I need it. Because at the end of the day, I did not load my fact tables in Power BI. I create tables or view my Snowflake and load those tables in use because I didn't need those fact tables. Much the big as they are, I didn't move them in this thing. So here is my golden conditions. Unfortunately, they're not um, optimized here, but let's see. These are um, these are my tables that I create, and these are the manual ones that I create for the price ranges that is needed for the filterings. As you can see, I have many of those lookup tables, but I wanted to show you some of my fact tables. You can see I have, sometimes I can be messy too. I have lots of fact tables, and in this project, I usually don't. I usually keep my fact tables minimal, but in this project, I had a lot of different types of data that I confused myself. Was um, banging my head against the wall for a month to see what type of analysis I can get from all of these data. I have a lot of data. So as you can see, I have 1, 2, 3, 4, 5, 6 fact tables only for historical prices. Average stats, coupon history, historical data, historical offer, historical buy box, and historical monthly sale. And none of these could be merged into one because they had all different sorts of data, which I couldn't do anything else about them. And 1, 2, 3, 4, 5 main facts: fact seller, fact offer, buy box product, which is a current product, fact product, which shows um, um, some information about the product that is not relevant to the price. For example, the title, the brand, and these kind of stuff. So the buy box is the one that stores not only the prices, the features comes from that buy box seller, and these kind of, and the seller name and all those data. So I have a lot of. I chose to do that because of a data which was so confusing and was put them. I null value. So um, for the dim seller, this is selected distinct ones. I assigned ID one, and here silver. We manually these, and actually I didn't need to like fix my silver layer. So my dealers is only a lookup table, all the seller name, their IDs. I apply, and as you can see, I have already closed my CTE here. So these are, I think they're. Oh, I know what it is. I'm going to explain it. This is the silver. I'm just going to move forward fast. I can show you the category build-up. As you can remember, we had the category table um, that showed for each product. It showed what category was in it, all the category hierarchical from the top category to the bottom category. So I had to perform lots of CTEs in order to capture one main category. And I can show you pretty quick here. So this is my dim category. So you can see, actually I was about to, I removed the parent category name, I didn't need that. But the main columns are category name, category ID, and parent category ID. And this is useful for me in Power BI to create this hierarchical. So in my category table, that are reading the category names from this lookup table and having the category parents makes this hierarchical categories from computer and accessories, computers and tablets. Within the computers and tablets, desktop, we have laptops. Within laptops, we have traditional laptops, and everything from to bottom, this hierarchical relationship, it gets created with this. And if I show you what initially category silver, you can see three. The first was a department. I assigned the category level 1, accessory computers and accessories, computers and tablets. Level 5, and leave category. And then next go to the next product. And I created that dimension category using this. And I used this one, silver category, to actually assign the product category in my table in order for this filter on Power BI works correctly. So whenever I select a category, the products in my tables gets changed. And I used my main silver category and assign the category ID in which that product is in from the top department to the leaf level here. So it's a dim category. I don't want to go deep into this SQL stuff, but it was a multiple CTEs I needed to perform. How much time do we have?
We're coming up on an hour, so why don't you
yeah, I want to be
spend
faster.
some time on the report.
Okay, so I'm going to move forward. I have my fact product, same thing here. I want to go deep into this, but lots of CT here. Price, which means the buy box prices, the features, lots of stuff in. It's a very long. My data analysis, example analysis, which I think is relevant for my Power BI. So the seller rate, I was thinking for myself to know a good product. That so in one of my tables that I use in Power BI, I have top seller rate. How will I calculate sellers? First of all, I give a where is this score coming from? Not they have 4.5, but also how many ratings they have, how many percentage they have, 4-star they have, 3-star they have, 1-star they have, with the multipliers, and also positive ratings in last 30 days. So you can see positive in 30 days has higher weights than 60 days than 90 days. For me, how this seller performed last month, and this is stable positive rating score. Another score was review weight, which is I didn't only use a total rating, I used a logarithmic value because like if the product has lots of ratings, that would increase the number and that we would just be unfair about it. And the catalog weight, also I forgot to mention, not only how many positive rates, 5-star, 4-star, 1-star they have, the rating, total number of reviews. Also, it depends how many product this seller is selling. So if the seller has thousands of positive reviews, but it only selling 10 products, is not as good as a seller who's selling 1,000 items and having 1,000 reviews. So the first one should be better seller because in less number of products they have more. So this is coming to one of my scores as well. After I calculate all, I put them all together. So my seller score is not only based on stable positive percentage, but review and catalog weight. So this one is a score that each seller will be applied to. And then finally, I will rank them based on this seller score. That's what we are going to see. Let me deselect this one. That's what the top rate. Let me go to the page for the sellers. That's what you're going to see here. Top 10 rated sellers. This rank that you're seeing here is, you see here that this seller, the first one, 85K ratings. It has 270K reviews, and it has 79% positive rate. It's in the first place. However, the second place has 96% positive reviews. We think that it should be the first, but it has only 4K listings. And as you can see, all of these weighted scores will affect on the ranking of the seller. So we can argue of the how many weights we should give for each of these elements, but these are all important. Was important in my opinion of how can I rate. And I actually, it was not completely my idea. I researched in a business section for how can you rate a product, and it made sense to me. And you can see the difference in the table, like the changes, like how we this rating actually makes sense. Another one that I wanted to show you the query, explain you how I came up with, was the Black Friday prices. Let me show you the Black Friday prices here. So as you remember, I said like I extracted the historical data and current data. Historical data helped me find the prices from that week of Prime Week during the Black Friday. So I filled from my historical data the prices in this time. Let me create a visualization. I to see how we perform prices during the Prime. So what I extracted, I don't know how good you can see it, but is the best. Like this here is right now on January 16, not right now, on January 16 that I extracted the product prices. This shows the different Amazon Prime Week. New price, it means that minimum price for the new content. Buy box Prime, it shows that the buy box winners price, and this is actually just like a column that shows which one was the best price. And from here, I was looking in to see how we performed and to see like how many of these products we actually put it on sale. So you can see this product was 75 on January, on Prime Week was 59, And as you can see, some of them was more expensive. I don't know why, but this product was $85 and $19. Maybe at that time, coupon was added to it on January or something was discount on it, but $19 is cheaper right now. This is what I wanted to see, and these are coming from the DAX queries within the Power BI. So I created a DAX, get the best price deal, and for each of these column I compared it with this. If it was more than this, make it like the different type of column. This was the main point for extracting information from historical data to extract the prices and compare my current prices with the historical price. In this case, from my historical price, now that on the topic of the historical price, is to see how we perform over. So I compared how Amazon did with the third party, and you can see the Amazon, like in comparison with the third party, the sale actually was more coming from the third party. It doesn't mean like it's people. It means that it fulfilled merchandise and Amazon is selling it, but it's not solely product Amazon, sold by Amazon and fulfilled by Amazon. That's what it means. And I also have a historical total monthly sale that I wanted to grab for whole 2025. That was the whole point of getting the historical data, and that shows my total sale and comparison with the revenue. And we can say we had more revenue, we have more sales, but fluctuating with the sale, you'll have good revenue. And sometimes that's not the case. In the previous Power BI dashboard I created, sometimes with more sales, revenue were coming down. It showed to me that maybe the products were sold was not that expensive, that didn't cause like good revenue based on selling like the high price, other high price products. I will be super quick. This is one of my Black Friday data. From my historical, I only filtered the data from this range of dates from November 20 to first. Did my and got the discount range, discount percentage ID level, and in this Pareto that we don't have time to go. Pareto chart, top 20% of product contributing to the revenue. I got to this sales and revenue. I calculate sale, cumulative sale, keep growing up like percent. The products here are sale. I have this is historical. I can show you the rest of the Power BI. This is my product. See, we have this amount of products. Total sales. Sales means sold last month, not any other dates. Total monthly revenue, our previous month's revenue, and total brands. We have 41 brands in computer and accessories department from the ASINs that I limited number of ASINs I downloaded. These are my filters, and you can choose. You can see you want to see top rated products in categories. You can choose what categories you're looking for: laptops, traditional desks, or whatever you want to choose. And whatever you choose here, it's gonna reflect visualization, I wanted them to be dynamic. So these KPIs, I wanted to keep them steady. Also, we have in our filters, we have ratings. So if you want to find the products that their rating is between 4 to 4 and above, you can select those. And then you have price range here. So you based on the most that Amazon uses. Price ranges by Amazon. I don't think this is something Amazon matters for the users, but for the company might matter. If you want to see how many of the products we fulfilled, like you can see the total monthly sale when we were fulfilling the product and when the merchant was fulfilling. We don't have data merchants. We have prime versus non-prime. We have different conditions for the products, and coming all from model that we apply the IDs into this table and reading the actual or dimensions. This is our stock availabilities also. And as you can see, if you don't have a data, it means that that product doesn't have a filter on it. This is our Pareto, and this is the result of the Pareto in nutshell. So it's when we don't have anything, 64% of the revenue comes from the 64% of revenue comes from the 20% of the top products, and this is all products, not sellers. Top selling products this is a rating based on recent month sale. You can see, and what I think from here is that it shows that the more monthly sale doesn't have anything to do with the rating. That's what you can tell. So this one had a very high rating, but sold much less than the first place that sold $10,000. So not always a good rating means that the sale is bad, but the person cannot tell that as well. 3,000, the 8th place was still very good. So with I thought like I can expand the project, the turnover on my on the accounts that I have in here on like whatever like implied suggestion on accounts based on if the product is high rating, let's put discount so the product sells. Let me show you some of this seller discounts. I already talked about Prime, but I wanted to show you the price comparisons. So you see the competitive price gap. This is the most suggested discounts, and the suggested discounts comes from different aspects. Comparing our price to the price, comparing final price to the previous historical average price of the product we're selling, right? Compare our on sale with the historical reason sale. Scoring same as the rating was applying to how much discount you want to get. We don't have time to show you the queries, but in a nutshell, I say if the for example, if the price if our price is higher than our historical price, right? Give some multiply by 0.5, for example. I think that's important for me. But in another example, if the product recent sale was lower than our recent month sale in 2 months ago, put 2.2, so lower weight on that. But at the end, I will have some scoring that I can apply to say what percentage of discount I want to apply to the product. However, I thought about one more thing. I thought like if I implement that calculation for $1,000 product, 20% as a say I want to put 20% discount. I want to choose the least amount of discount as I can. So I implemented a different strategy here. I said we did 20%, but if it was more than $1,500, the minimum, the maximum discount you give is 50%. So I will lower the discount. So here you can see the price was $9.99. Per price this amount, discount was 20%. This one, average price lower, our price higher, but 10% was the cap. So if I go ahead and go down, these numbers are, if I'm not mistaken, this is where our prices. I have to check my DAX application of what they're comparing it to. That I don't remember. Yeah, but here's the way that I come up with the scoring. Scoring is not just based on, are we spending more, $200 more? Let's put a discount. Multiple stuff comes when deciding the discounts. And here you can see hot deal products with 20% discount. Discount is $198 based on the higher price, the difference price. We have 29 from the product that we had, 29 overpriced, 38 was competitive. And by the way, I forgot to mention, I assigned a flag for assigning the discounts. Some of them I assign small percentage. Sometimes I do aggressive, and the percentage defines by that an average discount average that the bar we are having a high price is 7. You have to be competitive. It doesn't mean you're selling. It means that gap is that small. The medium application discount or small discount. This is how we define that. And we see here prices that are higher than the large competitors. $1,000 from 2 was this number, 200 to 300, and 1 was $100. And 38 didn't need any discounts. 13 was aggressive discount. 10 products were medium discount, and 6 was small discounts. And here we have, I forgot to mention this, we have the same type of visualizations for Prime. We had 391 products on Prime week was aggressively discounted. 187 was not discounted, means that the prices were the same. 73 was in clearance, the price was so smaller than the original price that we have. And this is a type of comparison type of page for my visualizations. In this, I think this is the seller's page. This seller page, it just shows the KPIs like total sellers. We have 2 Amazon sellers, Amazon.com and Amazon Resale. We have 18 third-party sellers, and the KPI is coming from this table, unbeatable sale Inc. with 85K sell total. Top supplier seller, but we want to see which seller sells more products on our platform. This seller with 332 selling. We see that 1K general non-prime is 60%, 9.9% prime. Most prices are fulfilled by merchant fulfilled. We have 10 rated sellers. We talked about it. Composite. The sellers versus the positive rates. We see like we have Amazon with most sale for the past month, and the reviews coming from it. The reason that it's zero is because of the lack of the data for Amazon ratings. So in my final rating that I had for, as I said, the Amazon was missing in the offer, so it didn't have any rating. So the data for the Amazon rating is incorrect. So Unbeatenable, that we thought is a top rated seller, only said 85K in comparison with Amazon, 79% positive rate it had, and it shows these kind of information here. And as before, we can switch around with these filters. However, they should be relevant. So whatever that you don't see they're changing, this is irrelevant. So I didn't want this one to be changed by the filters.